We are going to attempt to do some long division now. But I do want to show you a little bit where, in this case, it's actually easier to do factoring. And I want to show you how to do this to review some of the old stuff, as well as to prove this is the correct answer when we do it. When I do this, I have to find the factors of 12 that add up to 8. If I look at the factors of 12, I have 1 and 12, 2 and 6, 3 and 4. Clearly 2 and 6 is the correct pair. Now since it's a 1z squared, this is the easy factoring where we literally just split up the middle term using the 2 and the 6. So it's z plus 2, z plus 6, all over z plus 6. And just like we learned earlier in chapter 7, the z plus 6's go away, so my answer is just z plus 2. Eventually, we're not going to be able to find factors of this last number to add up to the middle number. And that's when we have to do long division and we have remainders. Now, if you do remember long division, and I'll do a quick one on the side here, let's say we do 3 into 475. I go, how many times does 3 go into the first number? Now 3 only goes once into it, so I do 1. 1 times 3 is 3. Then I subtract. 4 minus 3 is 1. Then I bring down the next number, 17. Well, how many 3's go into 17? Well, 5 times 3 is 15, so I write the 5 up there, 15 here. Then I subtract, and then I have 2. I bring down the last number, which is 5. How many times does 3 go into 25 without going? 8 times. That's 24. I have 1 left over. Then I do 158 and 1/3. Now, I know it's been a while since you've done some long division. This is, scarily enough, the easy one. Now let's go do the other kind. Sorry, my keyboard keeps popping up on me. I have to do z plus 6 into z squared plus 8z plus 12. So again, when I did 3 into 4, I have to look how many times does z go into z squared. Now, this I'm going to do in a little sidebar here. Let's see. I'm going to do this in a different color. I'm going to do z squared over z, which reduces to a z. So I'll go back to green. So that means my first number up here, or letter, is z. Now remember when I was over here, to get my 3, when I got my 3 here, I did 1 times 3 and got the 3 here. If I look at the 15 here, I did 5 times 3 and got 15. So what I need to do is I need to take the z and multiply it by both of those numbers and then write it underneath. So let's see if I can get back to green here. So now when I multiply, I can do z times z, which is z squared. Z times 6 is plus 6z. And remember, I have to subtract both of these. I'm subtracting. Now z squared minus z squared is gone. That's 0. Now I have to do 8z minus 6z. So remember, we're really transferring this minus sign to here, so it's really a negative 6z. 8z plus negative 6z is really 2z. Then just like the other ones, when I was bringing down the number, I bring down the next number, plus 12. And I know this is very weird, but practice and you'll be getting better at it. So now here I look at the 2z and the z. So I put 2z over z. The z's cancel, I'm left with 2. So I write plus 2 up there. Then I do the same thing. 2 times z is 2z. 2 times 6 is 12. I subtract both of those and I get 0. So my answer is z plus 2 here, and it's also z plus 2 there. I can just quickly highlight those two answers. They are the same. Okay. Now, clearly factoring is a much better way of doing this. And the first couple of them can be done by factoring. But once we get down to this question right here, it doesn't factor anymore, so we have to know how to long divide. This next one here, minuses are always difficult. We always got to be careful with our signs. If I do long division y minus 7 into y squared minus 6y minus 7. So again, my first step, put it in red here, I'm going to do y squared over y, which is just y. So I put top y here, and then I multiply. Y times y is y squared. Y times negative 7 is minus 7y. Now remember, I have to subtract both of those. So what that means in here, minus, so this is really a negative y squared, but a negative negative, that really means that second one is a positive. And that's where all the sign errors are made, are right there. So when I do this, y squared minus plus negative y squared is gone. Negative 6y plus 7y is positive y, or 1y. I bring down the minus 7. Now, how many times does y go into y? Well, y over y is just equal to 1, isn't it? So I put plus 1 up here, I multiply, and then 1 times y minus 7 is just y minus 7. And if I subtract both of them, y minus y is 0. Now remember, we have to distribute the negative, so this is really a positive. Negative 7 plus 7 is 7, so it's 0. So my answer is y plus 1. Again, this one factors. Scroll down here, we'll do a little more long division. And really, I just have these 4 questions that I'm going to be doing, 4 more questions. Now, this next one, I will highly encourage you to just factor it. We all should know this. This is the question I hammer away at. We got to just know how to factor this. How do we factor x squared minus 49? Well, it's subtraction. They're both perfect squares. It's just x plus 7, x minus 7. We put it over x plus 7. They go away. My answer is x minus 7. Okay. So now let's go to this next one here. What factors of 15 add up to 9? Now if I look at factors of 15, all I have is 1 and 15 and 3 and 5. Neither one of those add up to 9. 3 plus 5 is 8. It's close, but it is not 9, so I cannot factor it. So this will be the first time I will actually have a remainder. So when I do this, again, I do z plus 6 into z squared plus 9z plus 15. I write it out as a long division. As always, I look at my first 2 things here. So z squared over z just reduces to z. So the first thing I'm going to write up here is just a z. Then I'm going to distribute the z to here and the z to here. Z times z is z squared. Z times 6 is plus 6z. And remember, I'm subtracting both of those. Now these are all positive, so there's less chances of sign errors. Z squared minus z squared goes away, so there's no z squareds anymore. 9 minus 6 is 3z. And again, I bring down my next number, so it's plus 15. I go back, I look at my 3z and z. So I put 3z over z, the z's cancel, I'm left with 3. So it's positive 3 again, so I write plus 3. Again, I distribute. 3 times z is 3z. 3 times 6 is 18. And again, I subtract both of them. 3z minus 3z goes away. 15 minus 18 is negative 3. And I have no more numbers to bring down, so this is my remainder. How I write my remainder is I just put it up here, z plus 3, and then I write minus, and then I go 3 over what I was dividing by. I was dividing by z plus 6. So that is my answer, the first one with a remainder. Okay, and then all of these things, what's nice about my video here is you can always go back and say, what the heck? And then please ask questions. There will be questions, and I will demonstrate some of these in class coming up. Scroll down to the last two we're going to do for this section of the notes. This is going to be part 2 of 7C. Then we have lovely word problems at the end. Now these two get a little crazy. So let's do 6x plus 5 into 72x squared plus 54x minus 5. So again, I start off, I look at the first two things here. I do 72x squared over 6x. Now 72 divided by 6 is 12x. That's 12x. So I start off with a 12x up there. And then again, I multiply. 12x times 6x is 72x squared. 12x times 5 is plus 60x. Again, I subtract both of them. 72 minus 72 is 0. 54 minus 60 is negative 6x. Then I bring down the minus 5. Then I look at negative 6x over that. So negative 6x over 6x is equal to negative 1. So I write a minus 1 up here. Negative 1 times 6x is minus 6x. Negative 1 times positive 5 is negative 5. And remember, we're subtracting both of these. So really, these both turn into positives, don't they? So negative 6x plus 6x is 0. Negative 5 plus 5 is 0. So this actually goes in evenly. And this is my answer. Okay. Now this next one here is going to be the longest one. It's going to be the hardest one that we'll do. There's lots of minuses, which adds to the adventure, and I believe there's a remainder too. So let's set up a long division here. 3x minus 1 into 12x cubed minus 10x squared minus x plus 4. So we start off with looking at the 3x and the 12x cubed. 12x cubed over 3x. 12 over 3 is 4. X cubed over x is x squared. So that'll be the first one I put up here, 4x squared. So 4x squared times 3x is 12x cubed. 4x squared times minus 1 is minus 4x squared. But remember, we have to subtract both of these. So the signs, this is normally positive, that's negative. Now that's negative, so this has to be positive. We have to change the signs. 12x cubed plus negative 12x cubed is gone. Negative 10x squared plus 4x squared is negative 6x squared. I bring down the next term, which is minus x. So again, I'm looking at the negative 6x squared and the 3x. So negative 6x squared over 3x is equal to negative 2x. So I put the negative 2x up here, and then I multiply again. Negative 2x times 3x is negative 6x squared. Negative 2x times negative 1 is positive 2x. But again, remember, we're subtracting each one of these. So remember, now this is negative, so that's really a positive. This is a positive, so that's really a negative. Oops. So negative 6x squared plus 6x squared cancels. Negative x plus negative 2x is negative 3x. I bring down my last number, plus 4. I look at negative 3x over 3x. That reduces to negative 1. So I write my minus 1 up here. Negative 1 times 3x is negative 3x. Negative 1 times negative 1 is positive 1. But again, remember, I subtract both. So now this negative 3x is now a positive, and this positive 1 is now a negative 1. So negative 3x plus 3x cancels. 4 plus negative 1 is 3. So I have a positive 3 remainder. So this is the remainder. So what I do is I write out, since it's positive, I write plus 3 over what I divided by, 3x minus 1. That is quite the question. That is about a 15-minute video, so I'm going to stop here. I'm going to do the word problems in another video.